Right. Hello, everybody. I hope you can hear me. Thank you very much for coming along to today's Fall into Nature webinar from Plant Life. It is fantastic to have you here. My name is Ollie Wilson. I'm going to be speaking here today, and I'm here with Becky James, who you about my work with the National Plants Monitoring Scheme. But before we get into the actual meat of this webinar, there's a few little bits of housekeeping to talk about. The way that this event is set up on Zoom means that Becky and I can't see you and we can't hear you. So if there's a technical problem that we might be able to help you out with, type it into the chat box that you should see somewhere on your screen. Becky can see what she can do about that. And every now and again in that chat box, you'll also see relevant links popping up, giving you a chance to explore some of the stuff that I'm talking about in your own time. If you've got a question about the stuff I'm saying, then please put that in the Q&A box that you should see on Zoom. We're going to have a bit of time at the end of this webinar where I'll go through those questions and we can have a bit of a discussion about the things that we talked about. I probably won't be able to see or answer those questions while I'm focused on doing the talk, but we'll make sure there's some time set aside at the end. And lastly, as you may have heard announced quite loudly at the beginning, this talk is being recorded and it's going to be posted to Plant Life's YouTube channel in the next week or so. So you can share that link with people who you think might enjoy it. So that is most of the admin things out of the way. I'll introduce myself properly. My name is Ollie. I joined Plant Life in June this year and I work as an ecological modeler. I'm part of a smallish team here at Plant Life working on the National Plants Monitoring Scheme. I'm going to start calling that NPMS because it is much less of a mouthful. Away from Plant Life, I'm also coming towards the end of a PhD in paleoecology at the University of Reading. This is actually the second Fall into Nature talk that I've done. The first one was about my PhD and about paleoecology. And if that sounds like something that's interesting to you, I'm biased, but I 100% think it could be. Becky's going to pop a link to that talk on YouTube in the chat any second now. Feel free to go and watch that some other time. Don't leave it right now. And I hope you find that interesting. But in this talk, I'm focusing on the things that I'm doing here at Plant Life. I'm going to give a quick overview of the UK's incredible natural history data and to look at where the NPMS, the National Plant Monitoring Scheme, fits into that landscape. I'm going to give you a fairly brief overview of the NPMS, what it's for, how it works. Although that's not really the main focus of this talk, I am going to spend a bit longer looking at how we're putting the data from the NPMS volunteers to good use to help us understand how the UK's environment is changing. So, the UK has got unbelievable biodiversity data on its natural history. To illustrate my point, this is a map of data from the Global Biodiversity Information Facility, GBIF. It shows the number of animal genera, that's like the level above species, that have been recorded from the world. Did you know that we lived in like the hottest region of the world for animal diversity? More animal records than the Amazon? Well, we don't live in a hotspot of animal diversity. If we did, David Attenborough would spend much more time filming in Belgium than he has. No, the reason our part of the world, Northern Europe, has so many different animals in GBIF is because there are so many more biodiversity records in our part of the world than elsewhere. Really, the only other place that is similarly densely sampled for any kind of biodiversity data is parts of North America, only parts. If we had a real map of animal diversity, it would look a lot more like this than the first one I showed you. The UK and Northern Europe has got incredible data on its natural history. In fact, if we look just at plants, again, this from GBIF, you can see the same kind of thing. Northern Europe, especially the UK, has got more circles, bigger circles, redder circles, showing many more records of plant data than almost anywhere else in the world. Before we zoom in, I just want to highlight an interesting point here. You'll see this straight line of records here. They're all along the line of 0 longitude, the Greenwich meridian. Those records aren't real. It shows one of the problems of using data repositories like GBIF, but it also helps show why sometimes people worry about little flaws in their data. You don't need to worry about it too much. When we look at GBIF data and we zoom in on the UK, you can see that we have got brilliant data, even in the context of a well-sampled region, Northern Europe. But I want to particularly draw the contrast between the amount of data that's available for plants here in the UK, not just against places like France or the Low Countries, but places like North Africa, where data is far, far more sparse. You see, the importance and the value of the UK's incredible plant data only becomes more evident when you make comparisons like that. And you see this pattern in almost all data on natural history. Here on vegetation survey plots, you can see it when you look at climate records and weather stations. You can even see it when you look at things like this, fossil pollen sites. They help monitor changes in vegetation over centennial, millennial timescales. Now, maps like these ones have become slightly depressingly routine during my PhD research, as if you watch that video, you'll find out. So I've been looking at past and future vegetation changes in southern Brazil, and I see lots and lots of maps like this. Now, I've been extremely fortunate that I've worked with the team of people who help make this little corner of South America a hotspot for vegetation plot data. But as I do, if you want to work out data from vegetation plots to the local climate conditions, and then maybe tie the diversity and the links you see there in with past ecosystem dynamics, well, then you can see you're a bit stuck for much of the world, in fact, most of the tropics. That lack of data can really limit what you're able to do almost everywhere, apart from places like the UK. Now, data like this is important because our world is changing. It's changing more and it's changing faster than humans have ever previously experienced. So here we can see temperature records from the UK. You can see a really clear warming trend. The lines overall are moving up as you move from left to right. But part of the reason we can see this clear temperature trend is because we have got, again, fantastic data in the UK. You can see here in the bottom left, this data comes back 130 years, back to the late 19th century. It's fantastic data. Again, to belabor the comparison, but if you look in southern South America, a whole part of a significant chunk of that continent, there are only 19 weather stations that have anything like the length of coverage as we have in lots of places in the UK. In fact, you can get an even bigger view on the magnitude of the changes our planet is going through, our country is going through, and how good the UK's data is on that by looking at this. It's the Central England Temperature Series. It's been going ever since 1659, 360 years of data. It is absolutely unrivaled, and it very clearly shows the changes our planet is going through. It's not just the climate that's changing either. Our landscapes are as well. And here, again, in the UK, we can see that far clearer than you can almost anywhere else by using things like these old Ordnance Survey maps. I would love to have land cover data like this for southern Brazil. There's so much I could use it for, but it simply does not exist, much like my neighborhood here in the late 19th century. Here, you can see ecosystem change really clearly. You can see how the moorlands of the north of England have become forested in the last century or so. This is Kielder Forest. It was planted in the 1920s. In all of these examples, you can see not just how good the UK's natural history data is, but also the imperative of understanding how our natural world is adapting and responding to the changes it is undergoing. Now, as I've said, we are very lucky that we've got a lot of data on British wildlife, and much of it comes from a very long and proud tradition of amateur recording. In the case of plants, a lot of that recording has been coordinated by the Botanical Society for Britain and Ireland, the BSBI, and they have got decades and decades of data on plant records available. These data show interesting patterns, as you can see in these maps. So, for example, let's have a look at the distribution of oak trees in Britain before the black dots and after the hollow dots about 1950. We can focus on those oak records before black and after hollow 1950 in southwest England. We can see that oak trees were found in Cornwall and in Dorset before the 50s, but not in Devon, only after 1950. So did oak trees invade Devon from Cornwall and Dorset in the 50s and 60s? No, of course they didn't. This pattern is a function of different effort, different recording input in space and in time. Slightly more complicated, we can look at this more tricky example. We can look at lime trees on the island of Ireland. There are no records in the BSBI database from before 1950, and there are quite a few afterwards, but there are still some gaps, some areas with no circles at all. Now, is this an example of the species colonizing some new areas? Actually, it may be. It's not as clear cut as with oak trees in southwest England, but it's really hard to tell. Now, you can see slightly from the records of oak trees, but definitely from the daisy records, that Irish records, the older ones, have some kind of grid pattern to them. So feasibly, the lime trees were just missed in that grid. They were not quite there at that time. Maybe they genuinely were present, or maybe they weren't. And the species has started to colonize Ireland in the last century or so. It's actually quite difficult to tell. We can also try and use these records to look at abundance. We can use the number of records to try and get an idea of where the strongholds are for different species. Again, we can use the lime example here. But what this seems to show is that the strongest of lime trees' strongholds, the place which has the most records for this species, is London. So maybe there's something about London that really does it for lime trees. Maybe it's the climate or the soil or the underground or the high rents. Or maybe this pattern is just because lots of people live in and pass through London, and so the same small number of lime trees get recorded a lot. Now, these cases each help to illustrate some of the drawbacks, the potential weaknesses of opportunistic presence-only records like this, where people go out and they record the things that they'd find. We are immensely fortunate to have so much of this data in the UK, and there is tons we can do with it, but there is space for even more and even better data with which we can do even better things. We need to go beyond just this kind of dots on maps, because there is real value in adding some kind of data recording, biodiversity monitoring programs which have got structure that help to tell us which locations have been surveyed, when they were looked at, the amount of effort that went into the survey, and things like that. Surveys like that could really help us to clarify questions like when and why did the lime tree arrive in Ireland? And in fact, it could also help us to figure out where the genuine strongholds for species like lime trees are found, not just in places with the most opportunistic records. And there's a lot of value in having records that go beyond just saying which species are present. It's extremely helpful if you can record what is not there as well. That's why recording really boring looking plots is actually incredibly helpful. Best of all, not just what is there and what is not there, but how much of what is there. The abundance of the populations in survey plots is a gold standard for data collection. Data like that, abundance data from structured surveys, can really unlock a whole world of possibilities for helping us understand how British nature is changing. Now, the importance of data like this is not a shock. It's been known for a really long time. And that's why survey schemes like these have been up and running for decades, monitoring the UK's birds and bats and butterflies. But data like this has been surprisingly thin on the ground for plants, even though these schemes are incredibly important. There is the Countryside Survey, which provides an incredible overview of the UK's plants and soils, and which started in the late 70s. But unlike these other animal-focused survey schemes, the Countryside Survey has been a bit sporadic by design. So it means that we've only got a handful of data points from the last few decades. The Countryside Survey is moving to a more frequent rolling survey schedule, but it does mean that the UK hasn't had this kind of regularly monitored system to look at the health of the UK's plant communities and habitats. It's a major blind spot in our ability to understand how our environment is changing, especially at this very changeable time. As you might have guessed, this is where the NPMS fits in. right in the middle. The NPMS has been set up to provide that same kind of structured, rigorous annual data on the abundance of plant populations and therefore habitat health that we already have for lots of animal groups, and which the Countryside Survey has done sporadically over a much longer time. Back in 2010, a report by the Joint Nature Conservation Committee, which is a UK government advisory group, dreamed up an ideal plant surveillance scheme, decided that it would minimize the bias in its records. We've already looked at how opportunistic surveys can introduce biases in the records. Think London lime trees. It would help us to understand why those changes are happening. And part of that is that frequent sampling. So you can see what changes might be linked, what changes in plant communities might be linked to other changes in climate or land management or policy. Ideally, a UK plant monitoring scheme would generate data that can be used for biodiversity indicators, things that give a national picture of how well plants are doing, plant communities in the wider countryside in particular. And because it would have to rely on citizen science, on volunteer surveyors, a survey in an ideal world would be simple and repeatable, it would be fun to do, and it would bring in and keep volunteers who want to take part. The JNCC recognised a scheme like this would be incredibly important. As it says here, it would vastly improve the UK's ability to report on and respond to the state of the natural environment. This is the basis for the NPMS. This ideal scheme started to be brought into life over the years that followed. So the NPMS is a partnership. Initially, it was a partnership between Plant Life, us here, who kind of run the day-to-day bits, the UK Centre for Ecology and Hydrology, who have got a handle on lots of the science elements, as do the BSBI, with input from JNCC and more recently from Northern Ireland's Department for Agriculture, Environment and Rural Affairs. This partnership spent years testing and refining methods, working with volunteers to come up with a scheme that worked until in 2015, the NPMS was launched. And in this next section, very roughly, I'm going to talk you through how it works. Now, if you want more information on any of this, I strongly recommend you go and have a look at the NPMS website. It is definitely the best first port of call. I think Becky's going to pop a link into that in the chat. So the starting point for the NPMS is this. It is the UK's land cover map, specifically one from 2007. You can see that, as you would expect, the UK is covered in lots of different habitats, some of them extremely common, some of them much rarer, and therefore much more important, more valuable. What happened in the early stages was that this map was used to weight the different 1 kilometre squares across the UK based on how much nationally rare habitat each square had. And so squares with higher weight, more rarer habitat would come up higher in a draw. The UK was then subdivided into regions, those squares weighted by habitat importance, and a random subset of those squares was made available to volunteer surveyors to start in 2015. You can see here, this map might be slightly out of date, but not by very much. You've got been taken up in orange and ones in blue that are still up for grabs. Unfortunately, as you can see from the map and also from this diagram, those slightly less loved blue squares are not a random sample of all the ones available across the UK. Those blue squares tend to be in places that are colder or wetter. They have more peaty soils. They're also less populated, so it's harder for people to get to. Now, if you're looking at this map and you can see that there are blue dots in an area near you or a place you go on holiday or a place you frequently visit, please have a think about joining in with the NPMS, because data from these locations is super important. We need to have an understanding of how the UK is, how all of the UK's habitats are responding, and we really want to minimize all the blank spots we can on our maps. The NPMS does a brilliant job, far better than many schemes, of doing that, but these gaps are ones that you might be able to help us out with. If you want to explore that map and maybe zoom into places slightly closer to where you live, again, I think Becky's going to pop a link into that map, and you can follow that to sign up for the NPMS if that would be interesting and useful. Now, once you have a square, whether it is in a wet, a peaty place or somewhere in the sunny lowlands of near London, you get sent a lot of goodies, including a map like this, which kind of shows the predicted habitat areas in your 1 kilometre square. You can use this map to help you choose places to put much smaller plots, maybe 5 by 5 meters or 10 by 10, or longer linear ones. The idea is to choose plots that help you to characterize the habitat in your square. And with this and all the other information you get sent, you're able to carry out the NPMS survey. If you're interested, or if you do the survey already, you may already have come across it, but our volunteer coordinator, Sarah Shuttleworth, has put together some absolutely fantastic videos on how to choose places for plots, how to characterize the habitat of your locations, how to do absolutely anything to do with the NPMS. They're all on the NPMS support YouTube channel. There's tons of guidance there. If anything I'm saying sounds daunting or confusing, I really recommend watching her videos and talking to her about this, because she will help guide you through these steps. So once you've got your square, once you've got your plots within your square, it's surveying time. We encourage everybody to survey their plots twice a year, so late spring, late summertime, so you can capture the full range of changes that happen in the plants in your square. And then we're asking people to record what they find. And you can do this at 3 different levels. I'm going to start with the intermediate level. That level is called the indicator level. For every habitat, the people who set up the scheme identified about 30 key indicator species. Now, some of these species are positive indicators, which will show that habitat is probably doing fairly well. So for dry deciduous woodland, like here, a positive indicator is ramsons. You also have a selection of negative indicators. Again, for this habitat, something like stickyweed or cleavers is a good example. Nettles are a good example everywhere. The increased abundance of negative indicator species might suggest that this habitat is not completely healthy. So at indicator level, you are encouraged to identify and to characterize the abundance of these indicator species within your plots. You can record it at a level below indicator species, where you're given a subset of the more easy to identify indicator species. But you can also, if you're confident enough, work at a level above the indicator survey. And that one is the inventory survey, where you're asked to record absolutely every plant that grows within your plots. Then, whichever level you're working at, you tell us some information, either using the forms we've got or our nifty new NPMS app, a bit about your plots. Tell us where they are, tell us how they're being managed, and then tell us what plants you've found. Tell us what their identities are, and crucially, tell us a bit about how much of your plots each species cover. You can then enter this data online, or just let the app do it for you. After a little bit of verification, it ends up here on the UK's Environmental Information Data Centre, where it can be viewed and downloaded, used for research by anybody who's interested. And this is where I come in. And from my point of view, this is where the magic happens. Because we're not just running the NPMS to keep our surveyors busy, keep them off the streets and out of trouble. As we've already seen, the NPMS has an enormously important role in a very important niche in the UK's understanding of changing nature. So in this section, I'm going to look a bit at how the data from our surveyors is already being used to help us understand those changes to the UK's plant communities. I'm going to look at how it's already being used, what I'm using it for in my work, and then also to what other uses it might be put in the future. Because really, for the NPMS data, the sky is the limit. So the NPMS is already doing one of the things it was set out to do. It is contributing to the UK's biodiversity indicators. Now, indicators tend to look something a bit like this. This is the Spring Index. It's been going for most of the last 130 years, and it measures how long after the start of the year it's taken for orange-tipped butterflies, hawthorn and horse chestnut blossom, and swallows to appear in the UK. Overall trend towards those things happening earlier in the year, probably as a result of climate change. And there are similar indicators for lots of the UK's wildlife. Again, birds and bats and butterflies feature heavily here because these indicators are based really strongly on abundance data from those long-established structured surveys that we mentioned earlier on. Now, as we discussed previously, there is a bit of a hole here for plant data The Countryside Survey has provided some really interesting long-term overviews of species richness trends in the UK countryside, and looking at how many different species you find in different habitats. But it hasn't been used to look at abundance, and therefore it's not easy to translate this into the same kind of indicator as we see for other animals. And as we've already mentioned, because it's relatively sporadic, you can't see shorter term changes like ones in response to land management, changing agricultural policies, climate change, etc. Data from the NPMS, though, has been used to establish an indicator on the health of different UK habitats. It lets us see how they're doing year to year since 2015. So we can consider what might be driving the changes we see. An indicator like this helps us to try and improve the situation of these habitats. And crucially, having this year-to-year data on abundance helps us see if the changes we're making are having a positive impact. But at this point, I do need to add in a note of caution on the NPMS indicator. I'm going to take it from a world that might seem completely different. COVID data. Another area in which the UK has world-leading information. This graph shows how UK COVID deaths have changed through time. You can look at our current situation in October in two different ways. Deaths are a tenth of what they were at that awful January peak. So at the moment, we're doing fine. Alternatively, and equally, deaths are 20 times higher than they were at the start of June. Things are not going well at all. Each of these two viewpoints is backed by the data, but the fundamental difference is the choice of baseline period, how you anchor it to a frame of reference. Now, 2015 is a very recent baseline period for biodiversity change. As you can see here on the left from all these other indicators, a lot of change, positive but often negative, has already happened. When it comes to interpreting indicators, especially this one from the NPMS, we need to bear this in mind. Now, moves upwards on this axis always to be welcomed. It means that ecosystems are getting healthier, but we need to be really, really careful that the level of 2015 doesn't morph from a starting point to a target. Nonetheless, the longer we can keep the NPMS going, the better insight we have into the health of the UK's ecosystems and habitat. We can understand how they're changing and how they're coping with what we're subjecting them to. So that's a bit of insight into how the data has already been used. So now I want to have a look at what I'm doing with the data. And I'm focusing on UK plants and climate change. Hopefully, it's not too difficult to understand why that is. My talk on paleoecology looked at the long-term context for current climate change, and it really is scary. In about a century, roughly a lifetime, we're at risk of covering the same distance and temperature as would took 20,000 years from the last ice age to now. So we could, in the words of this illustration, call it an ice age unit within a century. Even if we enact really strict curbs on carbon emissions, we're still likely to get stuck at about one, maybe half an ice age unit. It's not like that's not going to be problematic. If you're interested in looking at this in more detail about how the UK's temperatures or how the world's temperatures have changed over really long timescales, there's a timeline that I think Becky's going to post the link to in the chat. It shows really clearly just how different the changes we're experiencing now are from changes that have happened naturally over longer time periods. And we can see that again using the Central England temperature series. There has been a generally slow, but more recently quick shift towards warmer temperatures. So it's not as though plants are only likely to experience climate change in the future. Plants have already experienced climate change. They might still be adapting to changes they have already experienced. So seeing how these changes are being experienced, seeing these responses in action, and predicting and catching future ones is going to be a really, really important piece of research. So part of what I'm looking at now is seeing how the UK's habitats are exposed, to assess the exposure of UK habitats to past 20th century and future 21st century climate changes. And we can have a look at this using, again, brilliant data from the UK Met Office. Here on the left half of the screen, you've got data on temperatures from blue, colder, and red warmer in January on the top and July on the bottom. On the right-hand side, we've got rainfall from black, very little rainfall, to sort of whiter, lighter blue colors for very high rainfall. And we can see that in the early 20th century, this is roughly what the UK's climate looked like. Sort of later in the 20th century, you can see it was perhaps a little bit warmer in the summer, maybe a tiny bit drier in the summer, but not an enormous amount of change. As we move to the last decade, we can see that there is a very definite warming trend and also more changes to rainfall. But we're not just restricted to this fantastic data for the UK's climate in the future. So we see for the coming couple of decades, a move to even warmer temperatures in both winter and summer, drier summers and wetter winters that become exacerbated if we do nothing about climate change by the end of this century. And that has a big impact on how you might characterize our climates. After minor changes, but relative stability through the 20th century, we can see as you move to the very recent past, reductions in these darker colored highland colder climates in Scotland and Northern England that become almost completely eradicated later into this century, even in the coming decades. We also start to see the emergence of climate types that have got really no analog in modern UK, across the UK in modern times. We have warm summers that are dry, which doesn't happen at the moment, as everybody knows. And again, if climate change isn't reined in, we can start to see dry and hot summers across much of the UK, from Devon to Doncaster. We need to understand what these changes are going to mean for the UK's habitats. And so this is another way of looking at it. You kind of break down the climate variables into a few key gradients. On the top here, we've got a gradient from warm and dry, relatively, on the sort of more orange end of the spectrum, to cold and wet at the more purple end of the spectrum. And on the bottom here, we've got a spectrum from sort of orangey color, kind of especially winter rainfall, to slightly more constant climate conditions in the purple. And again, we can see how the climate has changed, and we can see the magnitude of that change through time. So between the early and sort of later 20th centuries, the amount of change here in this left-hand map is really very small. It's not nothing at all, but the amount of change is not great. If we compare the late 20th century to the present day, the lifetimes of many of us, in fact, even almost my lifetime, we can see that the change is quite significantly more. In particular, again, you see this warming trend across much of the UK and this increase in winter rainfall. But the changes that have happened are going to be dwarfed by the changes that will or might happen in the future, looking over the next couple of decades and towards the end of this century. So we can map the distribution of UK habitats to the distribution of UK climate change and see how the two are linked. And this shows us which UK habitats have been most exposed to historical climate changes and which are most exposed to them in the future. Slightly surprisingly, and again, I need to emphasize all this data is preliminary at the moment, that some of the landscapes that are likely to experience the most climate change are ones that have been profoundly modified by people: arable and horticultural land, urban and suburban land, habitats, places where we live and work, and the places that give us our food. There's also a huge impact or exposure of climate change on some really important natural habitats. Calcareous grassland has got the second highest total exposure to past and future climate change of all the UK's habitat types. And this is one of the rarer habitats in the UK. In fact, we can have a look and see that lots of grassland habitats, which are a focus for plant life at the moment, are exposed quite significantly to climate change. Neutral, improved grassland being even more exposed than coniferous woodland. Ditto acid grassland here. So we can see how the changes in the UK's climate are likely to take these areas, these habitats, out of their current climate space. We see them kind of moving from the coloured shapes here progressively further away as time and global warming continues. But it's reasonable to look at this and to think, this is interesting, this is slightly worrying and informative, but it doesn't actually yet involve the NPMS. But this is where the NPMS really comes in, because as part of this research, I want not just to assess how climate change is likely to affect or how exposed UK habitats are to climate change, but also how well we can capture the effects of these climate changes. And this is going to be one of my jobs for this week coming up. I'm going to look at how the NPMS plots and the countryside survey plots and other UK ecosystem monitoring networks cover these gradients of climate change in the UK. Do they sample the places that are more and less exposed to climate changes? Are we likely to be able to see these changes that we're worried about? Or are they going to be slightly masked? I am very confident that we will find that the NPMS has a really important role in helping us to capture these climate changes that without it, we might be much more blinded to. The second part of my research kind of builds on this and is very similar to this study, which took place in France a few years ago using quite a similar citizen science survey data set. This study looked at the thermal preference for France's plant communities. So we can make a rough guesstimate as to what kind of temperatures different plant species like. And you can see whether plant communities were having more warm adapted species becoming more abundant as time moves on. And what we can see when we look at all plant communities in France from 2009 to 2017, there was a general move towards higher temperature preference. Ones that are able to change more quickly. And we can also see the areas that were more exposed to greater climate change, temperature change, had a slight but statistically significant increase in the amount of change they saw. The NPMS, with its fine spatial scale, its annual temporal resolution, and its coverage across the UK, is going to give us a really good opportunity to repeat this study, looking at the UK to see what changes have already happened to the UK's plant communities, to our habitats, in response to those climate changes. It's going to give us the best chance to see whether areas that have been more exposed to climate change have changed more, or are they still lagging behind? Are there places that seem to be more protected than we might expect? Questions like this are going to be incredibly important for understanding what our natural world is going to look like when I'm old and when I retire, when my kids get old and retire. The NPMS is going to play a really important part in helping us to understand what we do with these changes, to see them happening and to react to them. And this is just work that I'm planning to do in the next year or two. There is so much more the NPMS could be put to. We could look at nitrogen pollution and its impact on plant communities, which is enormous and very little studied. NPMS data, again, by being really fine scale, could be enormously important in developing habitat maps like the ones that you've seen throughout this talk. That they're derived from satellite images, but they need to be what's called ground truth. We need to know that what they're predicting is correct. And having on the ground plots is incredibly helpful for figuring out if that is right or not. Again, a potential use for the NPMS. We can look and see whether agricultural schemes and changes to policies are having positive or negative impacts on plants in field margins. We can do all sorts of things with the NPMS data, and all of it stems from the same starting point of people requesting squares, setting up plots, and identifying plants to send us the data. From this, all these other uses of NPMS data flow. The NPMS is going to be incredibly important. It has already been incredibly important at understanding how the UK's plants are changing in this incredibly changeable time in our natural world. That importance is only going to grow the longer the NPMS keeps going and the more data we're able to acquire. I hope through this talk, I've been able to give you some helpful insights into just how valuable the NPMS data is, about its position within the pantheon of UK natural history data. I hope I've given you some insights into what the NPMS is like and how it works, maybe even inspired you to give it a go if you haven't yet. And I hope I've shown you why that data that you're producing is so, so important. I wouldn't be able to do my how the UK's natural history is changing would be much the weaker without it. So thank you for coming. Thank you for tuning in. If you have questions you'd like me to answer, please pop them in the Q&A and I will do my best to get through to those. You can also take part in other ways. As I've said, please visit the NPMS website, have a look at the squares that are there and consider signing up or suggest it to someone else that they might like to sign up. You can become a Plant Life member and support us, and I'll work through that. And there are lots of other things, some of which are listed on this slide, you can take part in. So thank you for coming. And in just a moment, I'm going to start responding to any questions you have. If you have some that are on your mind, please pop them in the Q&A box, and I'll get to those in just a second. Thank you. Right, so a few questions here already. The first one from Robin is it possible to hindcast the index to give some context to the 2015 baseline? Now that is a very, very interesting question. And again, as I've mentioned a few times in this, I've got a background in paleoecology. So looking to the past for context is a really helpful, important thing from my point of view. I think one of the big challenges for that 2015 or for extending back into time that 2015 baseline is simply that the data it's based on, that index is based on, doesn't exist. That data is derived, that index is derived from the NPMS, and there was no NPMS data before 2015. Now, it might be possible to kind of identify places that were sampled in a similar way and look back further in time. It could maybe be possible to tweak the countryside survey data and try and get a similar index out of that to look at it further back through time. But fundamentally, it's difficult. And that shows why it is such a shame, as always, that plants had been neglected for such a long time. But it also shows the real importance for looking ahead to the future. So we can start to get an idea of whether the 2015 level for that index was high or low, whether it's easy to reach above it, or whether we struggle to even maintain it. Sadly, some things can't be brought back when they're gone. It's one of the things people say about extinction, isn't it? Extinction is forever. But not having that data is a shame. Having it now and being able to use it from the future is certainly the next best thing we can do. That's a really good question. Thank you. Another question from Victoria is, can work with UK data inform global analyses on climate change, especially when we consider that the largest changes in impact are likely to occur in areas with biodiversity data gaps? That's a super important point, yes. And it's something I've been in several meetings about recently, about how it's tempting to bring together all the way and to take out from that results that we can then say apply to the whole world. Whereas in reality, they only apply to the places where we have lots of data. So often not places like Brazil. Yes, is the short answer to the question you asked. Can it inform global analyses? Absolutely it can, because those global analyses always depend on the ground data. It goes through various filters, different people get their hands on it, but fundamentally, data like this is really important for any large scale analysis. And it's important that we have it wherever we have it in as good a quality as we can possibly manage. So occasionally we get emails from people who are putting together Europe-wide or even wider syntheses of biodiversity data. And the NPMS will help to provide one of the best ways of looking at UK environmental change that exists. And so because the UK and changes to our biodiversity are part of that global conversation, then the NPMS absolutely will have a big impact on that bigger, broader, more global question. Beyond that, there's also the point that the NPMS methods, rather than solely the scheme itself, are a very helpful way of understanding environmental change. So there's a project that's getting underway to try and roll out those methods more widely, so that if, I don't know, you're a council, or say you're surveying somewhere else, even in another country, then you've got a scheme, a survey technique that kind of speaks to, can be easily translated across different different situations, different contexts. So in that sense, having the NPMS techniques, the NPMS survey scheme, kind of help to understand climate changes and vegetation changes outside of the UK. And then there's other things as well, where you can use NPMS sites to be, you can involve them in the butterfly surveys or other things like that. So there's definitely ways the NPMS data and the kind of work we're doing here can be applied more widely. And in time, as the rest of the world acquires even better data, the techniques we're now able to do in the UK will be applicable further afield as well. Trying to think, one of the other questions we often get is around boring plots, and I kind of alluded to it early on in my talk. But one of the things that people often find with schemes like this is that they go to somewhere and frankly they find a place where the plants are not that interesting and there's nothing much going on. The temptation is often not to do anything with that, but I really want to urge you, if you're worried about it or you're unsure, please send us boring data. You might remember when I talked about the dots on the map showing the lime trees and oak trees and daisies from the BSBI data. Knowing where species are not gives so much context that helps us interpret data on where species are. It is really, really valuable. And so whether you're recording something else, if there is an option, send in your boring data, because boring data makes the interesting stuff far, far more useful than it otherwise would. Right. I can't see any more questions just for the moment. If you have any and you're wondering whether this is the right time to do it, please pop them in now. Failing that, we'll give it a couple more minutes and then I think we might bring the webinar to an end. But if no more questions come in, I just wanted to say again, thank you so much for coming. Please explore the links in the chats, and I believe that they might go around in the follow-up email that Becky sends later. I hope they're interesting. If you want to find out any more, please go visit the NPMS website or watch the NPMS support videos on YouTube. I hope they're interesting and informative, and I hope you have enjoyed this talk. There are still some more happening as part of the Fall into Nature event. You can go onto the Plant Life website to find out a bit more about that. But otherwise, thank you very much for coming, and I hope you have a lovely rest of the day. Thank you.